Welcome back, everyone, to Office Hours Unplugged in a very special episode today where we are chatting with the co-president of the iGEM McMaster team. And we are joined by Jiawen, as I mentioned before, the co-president. Could you please introduce yourself to our viewers?
Yeah, hello. My name is Jiawen. I'm a third-year biochemistry co-op student. I am one of the co-presidents of McMaster iGEM. And currently, I am a co-op student in Dr. Bramson's lab.
Okay, awesome. Could you tell us a little bit about your journey towards research and getting into the Bramson lab? Like, did you always know as a first year that you were interested in research and that was the field, you kind of wanted to pursue?
Yeah, so, coming into university, I really didn't know. I didn't know what was out there. I knew that I had a general interest in biology and chemistry, perhaps, so I was thinking, maybe I'll specialize in biochemistry, so I entered in the Life Science Gateway. I had no idea what research was or what it looks like or all the different types of research that exist, even just here within the McMaster community. My first introduction to it was actually iGEM, and so in October of my first year, I saw that there was this, info session for a club at McMaster called McMaster iGEM. And funnily enough, over the summer, they had requested to follow me over Instagram. And so I honestly did not know who they were. It was just kind of in the back of my head. I didn't really get to see them at Club Fest, but I saw their promo for this event. I went and I thought it was really cool because it was these undergraduate students giving this really formal presentation about the work that they had done. And they'd even published previously a review paper in Frontiers. And so I felt the aspect of, I was just impacted by how cool it was. I didn't really understand what they were saying because again, I was a first year.
Fair enough.
I didn't know what a genetic circuit was, but I thought that this might be really interesting. So I applied. It was a 2-ish month application process. And I don't even know how I was so surprised that I made it in, but I was really happy because it's something that I really wanted to do. And so in January of my first year at university, I joined the McMaster iGEM team on the wet lab team as a wet lab member. And even then, I still didn't really understand what synthetic biology was. We had to read a paper for the interview, but that was my first proper introduction to it. And so going through that year and spending the summer in the DDAR lab, I learned a lot more about what research might look like. A lot of the basic techniques of for example PCR. We did Golden Gate assembly. We worked in the BSc. I was there for part-ish time volunteering, so maybe 3 times a week.
Right.
And so I learned a lot about generally surface level what research looks like, how to digest a paper somewhat well. As a first year, you're sort of limited in your capacity, but you do your best. And after that, I was this is pretty cool. I kind of want to do more. I still don't have a good understanding of what exactly scientific research is. And so in my second year, I actually spoke to the lab coordinator at the DDAR lab, who we kind of worked adjacently with. We met her around the summer, and she said that we're open to hiring undergraduate students, or if you're interested, let me know. And so I emailed her being let me know if there's anything I can help out with. I want to do some volunteering and see. And so I think I got pretty lucky. I feel a lot of getting scientific research opportunities does boil down to luck at some point or to some degree.
Yeah.
They had a project called the Fendex project. It's a startup or spin-off from the DDAR lab called Fendex Technologies, and they work on antimicrobial surface sprays, surface coatings, and stuff like that. And so they just happened to be looking for one undergraduate volunteer to help out. And I know Dr. Soleimani was here last week.
She was, yes.
And so it's a joint project or joint effort between the Soleimani lab and the DDAR lab. And so I was directed to the lab manager at the Soleimani lab, and I worked under her from November 2024 to just this past December. And so for 1 year I was working under her. Her name is Janelle. She's absolutely amazing. She's a microbiologist. And so I was on more of the testing side. So in the DDAR lab, they made these fabrications. They were testing out different nanoparticles and compositions to see what kind of repelled bacteria, prevented bacterial growth the most. And then on the Soleimani side, we were doing the actual testing, like, does this actually prevent bacterial growth? And so I was doing a lot of microbiology work there, and I did get to see a little bit of the fabrication side, which is really cool to be under a co-supervised project. You get like 2 parts of it, 2 different labs, a lot of different experiences. And yeah, so that was kind of like my introduction, formally, I guess, to like supervised volunteer work within research, which is a really great opportunity. I learned a lot of technical skills. It was very great.
Yeah.
And then in that like second year, I became the wet lab lead, or one of the wet lab leads. And so there's a lot on that side of like reading a lot more papers and trying to develop our own protocols. And so the summer afterwards, summer of 2025, I believe.
That would be.
Yeah, I was like full-time in lab as a wet lab co-lead. And so we were working on our project, which I guess I'll be able to talk about more later. But we were developing our own protocols and testing things out across the DR lab and the Bramson lab. And that was like a really different experience because as a volunteer, like a lot of the times you're kind of working under your supervisor and like doing what like protocols they show you how to do, and you kind of just like do the work and kind of play a little bit in the role of analyzing, but not too much. Whereas in some cases, with the iGEM side, like everything from start to finish, from literature reviewed, protocol development, your actual experiments, your analysis, your write-up, everything is yourself. And so there's a lot to learn, but there's also there's a lot to learn. But obviously you make a lot more mistakes, but like it's a really valuable learning experience. And you get to work with a team.
Yes.
It's very cool.
Yeah. Just kind of just backtracking to something you mentioned earlier. Dr. Soleimani did mention that project briefly.
Yes.
Yeah, she spoke about it. That's really interesting that you actually worked on it too.
Yeah.
I had no idea. So could you tell us a little bit, maybe broadly, about what iGEM itself is as a competition and how it kind of like began, maybe?
Yeah. So the iGEM competition was founded, I believe, in like 2006 at MIT, and it started as sort of this. We wanted to be like this hub of synthetic biology. It wanted to be a space where people from all around the world can like kind of come together and try to progress the field of synthetic biology further. And so a lot of the huge advancements that exist within synthetic biology actually stem from the iGEM competition.
Wow.
The way that we like develop or like modulate genetic circuits, there's something called BioBrick, which is a mode of like plasmid assembly that is like from the iGEM Foundation. They develop that, and so like all the iGEM teams come and like contribute to that. And so the iGEM competition started out at MIT. It's now broadened towards like the international scale. Each year they hold a competition in Paris, France, called the iGEM Grand Jamboree. And essentially like you get 1 year where it's, teams from around the world, so universities, even the high school level, even the graduate level, there are teams that form and they kind of develop whatever project they want that uses synthetic biology to address some kind of real world problem. That's the focus. You want to leverage existing synthetic biology technologies, make your own advancements, but make sure that they're addressing a real need that people are actually facing. And so that's kind of what the iGEM competition surrounds itself around. And so each year, for us, from around like November-ish all the way till the next cycle, so the end of October or November, we work towards developing this project. And there are lots of phases. There's something called the iGEM cycle, which is sort of like what they frame this project development process around. So you spend the first couple of months like doing research and developing what your project is. So in the summer, actually going in lab, validating it, working on everything else also. iGEM is not just wet lab. And then you spend like afterwards writing it up, preparing for the presentations, a judging session, and then you go to Paris, France in like October, November, and you present and you talk to other people. So cool.
That's amazing. Yeah. And like before getting into like the details of the iGEM competition, I'm curious, could you talk a little bit about like the challenges you faced or any, I guess, interesting situations that you had to encounter during your preparation for the iGEM competition? Like I'm just listening about it is just making me nervous because going to Paris, presenting, oh my God, that's crazy.
Yeah. So, I mean, the biggest challenge I feel like is that because we're like an undergraduate team that obviously we have our principal investigator, we have our principal advisor, but developing the project itself is kind of purely on the students to do so. And so organizing that effort and making sure it's thorough, that you aren't, things happen, right? That sometimes you have to pivot your projects, and it gets very difficult when you receive feedback that what you've been working on may not necessarily be an actual problem that needs to be solved, or may not be the best way to approach that with the solution you had proposed. That is like a huge challenge that we face like continuously all the time. I'm sure all iGEM teams face that. And so I think the biggest thing to learn from that is to talk to people, to talk to as many people as you can to get a bigger, like a more holistic understanding of what your project could actually be and what may or may not work. And that is something obviously that is difficult because it's hard to get a hold of like these esteemed professors as well, because we are undergraduate students, and so it's a continuous effort that I'm also sure you guys have experience trying to get props on the show as well. But I mean, you guys have been doing amazing so far.
Thank you
so much.
Yeah.
So I just want to understand, so the main iGEM competition is comprised of essentially the wet lab project, and then there's also a dry lab aspect of it, which I'm assuming is more analytical or like bioinformatics.
Yeah, so the core like research components of an iGEM team, there's wet lab, dry lab, and human practices. So wet lab is what you kind of would think of. It's going into lab, working with like bacteria, whatever organisms you're working with, and like getting the data. Some teams, the wet lab team does the analysis. If there's any like statistical analysis and things like that, like sometimes the wet lab team does it, sometimes the dry lab team does it. For us, and historically, the dry lab team does a lot of modeling. So for example, you can model molecular dynamics. So how are like a protein and an RNA, how are they interacting? And how does that inform the decisions that your wet lab team makes? They can also do a lot of, like, they can do, like, AI and machine learning, too. You can build models to, like, optimize your workflows as well. On the dry lab side, there's also, like, a hardware component sometimes. So last year, our hardware, or, like, we had a little hardware subunit of our dry lab team. They, like, 3D printed, like, the cassette in which our device would theoretically sit on or exist within. And there's also a lot more that you can do within dry lab. I personally am on the, like, my experience has mostly been with the wet lab, and so I can't say too much about what dry lab is doing, but there's a lot of cool stuff that happens as well. Yeah.
And how about the human practices side of things?
Yeah. And so the human practices side, a really big focus of iGEM is also like real world impact. So one of the things is like, how can you translate what you're working on in your project to the general public? This is like a lot of science communication. There is a science communication branch of our team. And so last year they made like animated, like hand-drawn animated modules, like video animations, explaining like the process of how do you choose a biomarker and how does this play into like therapeutic development or diagnostic development. We have the entrepreneurship, where they build like a business plan for our product that we are proposing. And then we also have an outreach. So they work with a lot of like local communities. They have been doing workshops with like Hamilton schools, elementary schools, middle schools, high schools. We worked with SHAD last summer too. So just kind of to make the impact of science and synthetic biology more apparent in the real world, essentially.
Yeah, that's what science is all about, right? All this collaboration, it has to be multifaceted to get every aspect and make sure there's no like gaps or any room for error. 100%. So that makes so much sense, and that's really amazing. So now moving more towards what everyone is probably waiting for, the actual competition. So for last year's competition in Paris, your team came upon a pretty good amount of success. You won the gold medal, of course, a top 5 diagnostic project, and top 5 best measurement prize. Can you share more about the project REACT that you applied with?
Of course. So REACT itself stands for the Renal Ease of Use Assessment for Clinical Transplants. It is basically a point-of-care diagnostic to assess like kidney transplant patients and whether or not they are undergoing rejection or some kind of dysfunction with their transplant. So we talked to a couple of clinicians around Canada, and one of the big problems that they informed us about is that with kidney transplantation, the actual treatment of rejection and related symptoms and conditions is basically just to administer immunosuppressants. But the main reason why so many transplants fail is because that rejection is not caught early enough. And at that point, even if you do administer immunosuppressants, there's so much tissue damage that it's irreversible.
Right.
And so point-of-care diagnostic, rapid and costly, is like a huge, kind of like the field that felt like it was the most needed at the time, and even now I'm sure. especially for communities that are more remote to like transplant clinics, and is less accessible for them to do routine checkups.
Right.
And so what we ended up doing is we based our project off of an existing paper that had this system where you have like an aptamer sequence. I'm not too sure how familiar the audience is with aptamers and DNA enzymes, but you have a single-stranded piece of DNA, that can bind a protein. That protein would be like some early biomarkers of kidney dysfunction or dysregulation. So in our case, they were NGAL and CXCL9 are what we went with. And once it binds to the aptamer sequence, it can induce kind of like an amplification that can induce some kind of signal output. And so that was like the main kind of system of our project, and we put that on like the cassette that I mentioned before, where you would like add a drop of urine theoretically, and then you would incubate it with some reagents, and then it would turn out some kind of color change, and that would tell you what the concentration of your initial proteins were. You can scan it with a phone app that our dry lab team also developed.
Wow.
And then theoretically, like, you can send it to your clinicians, and then they can more easily monitor whether or not you have some early signs of concern that may need to be addressed.
That's amazing. Oh, I didn't know aptamers was involved. I know you were a part of the Lee Lab, so our audience has heard of aptamers.
Yeah.
We love aptamers
several
too, right?
times. I think they're probably tired of it at this point.
But they're so useful.
Yes, they're
And I'm curious. I kind of sort of have an inkling of an idea, but what made you choose to specifically hone in on kidney transplant rejection?
Mm-hmm.
Yeah.
And so kind of the way that we went about it last year we had a couple of contenders of the application that we wanted to apply that existing system that we had in mind. One of them was like sepsis, the other, I can't remember right now, but like off the top of my head, but it was between a couple of them. And it was like thrombosis. And we were kind of like talking to stakeholders around and seeing what was the most feasible. And from the clinicians that we had talked to, it seemed like kidney transplantation was something that we might actually be able to contribute towards, whereas like sepsis treatment is such a vast and a ridiculously difficult issue to resolve. And the kind of biomarkers we had in mind were not too like robust. They weren't as good as clinically validated. And so it's not necessarily like the route that sounds the most nice, but it's kind of what ended up happening. Yeah.
And were there any specific challenges? I know you mentioned, right, like coming up with these ideas, and I guess kind of being self-run is its own challenge. But I'm wondering, is there any specific challenge you ran with the REACT project in particular that is like very notable to you?
With the REACT project, we had, like, I guess only I can speak on the wet lab part of it. We had a lot of difficulty with actually, like, purifying our DNA sequences, getting the yield that we wanted, and actually, like, seeing their functionality within, like, amplification. So we did rolling circle amplification, which is, like, an alternative to, like, PCR in some capacity. We had a lot of difficulty, like, getting our circles purified and our primers, like, actually, like, seeing that amplification occur robustly. We got, like, a couple of nice tries that we definitely, like, featured really hard on our wiki and our presentations, but our wet lab validation itself was not as robust as we would have liked it to be, which is fair enough, because there's a lot of learning that comes with this kind of work. And, like, we have 4 months in the lab. In reality, we had maybe 2.5. And so to get to the point that we did, we saw some bands on our gels, like, things were looking okay. Like, we were very happy with what we were able to achieve, but,
I think with the time you had, I think you guys did an amazing job, honestly. I took a look at some of the gels, and I think you guys did a pretty good job.
Thank you.
So I want to ask, I mean, a lot of the work that you do is kind of informed by the input of clinicians, researchers. Were there any researchers in particular that helped you guys throughout the process? I know Dr. Didar is your sort of PI that kind of oversees the team. And then what role does Dr. Bramson play? Is he like the also another?
So he is our primary advisor.
Oh.
And so there's like a difference in the role that they play. Like, the primary investigator on, like, the team logistics side, like team registration, fee payment, all that runs through Dr. Didar. Dr. Bramson is our primary advisor, so he mainly acts to, like, in the same way that Dr. Didar would, they give us input and provide, graciously provide us with lab space and kind of feedback on the updates that we give them. their labs have been like immensely important in helping us like, redirect and try to get the most that we can out of the experience too.
And were there any other researchers or people that you reached out to and collaborated with?
Yes.
Because you mentioned some clinicians, right, who mentioned that they had problems with kidneys.
Yes.
Do you remember like a few on top of your head? Not to put you on the spot, but...
Yes. So we did meet with a clinician, like a transplant surgeon, out of the connections of one of our wet lab members, and he was able to tell us like what his patients are actually experiencing and the issues that he is experiencing in the clinic. We talked to Dr. Tom Blight-Hansen from BC. He works in pediatric nephrology, so he works with like pediatric patients, and in the same vein, like transplant patients, and like he really sees the issues of like that they experience once they have received their kidney, but they're not able to continuously go back into the clinic as routinely as like rapid detection would require. We talked to a lot of researchers. We talked to Dr. Julie Ho, who gave us a lot of insight onto the biomarkers that we had looked at, as well as Dr. Christine Ribick, who they're both working at McMaster in the Department of Medicine in nephrology, and they gave us a lot of insight into, again, like the biomarkers, the scientific side, also in kind, like patient experiences. Yeah.
And was your focus towards, you mentioned aptamers earlier, so was your focus towards functional nucleic acids inspired by a certain prof? Or was that an idea the iGEM team came up on their own?
Yeah. So in the beginning, we kind of knew that we wanted to work around like RNA amplification or some kind of like functional nucleic acid amplification technique. We played around with a couple of ideas before landing on rolling circuit amplification, which was actually like recommended to us by Dr. Bramson. And so we went down that entire rabbit hole. We talked to a lot of people in the Lee Lab as well. Which is very, very helpful. Shout out.
No, thank you.
Yeah.
Yeah, and just to ask, what made you go with functional nucleic acids as sort of your medium for this sensor? I mean, you probably had a wide range of options. I mean, why functional nucleic acids over everything else?
In the beginning, in like January, February, we had a lot of like very, very, very rough ideas playing around. One of the members came across like toe hold switches, and for a long time that was kind of our fixation. We wanted to, like, it was a really cool regulation mechanism for gene expression. We wanted to see what we can apply it to, and we tried to kind of morph it in a way that would help regulate some kind of amplification strategy, but in the end it didn't really play out too nicely. And so that's kind of like, I guess we were kind of always in the field of functional nucleic acids. We didn't know it at the time, but we kind of like were intrigued by it.
Right.
And so we kind of stayed in that. So there wasn't really a particular reason why we were like, FNAs are the way to treat this condition or this problem. But it was kind of like a natural drawing that kind of came to be.
Yeah, that makes sense. And then now you're the co-pres, right? But you mentioned previously you were the wet lab lead. I'm curious, what was it like managing people in such a, ambitious project? And were there any challenges with, both doing the wet lab work while also making sure, everyone is on the same page, everyone's working together as well?
Do you mean like being the wet lab lead versus the co-president? Or
no, just like wet lab lead as its own.
Lead?
Right, yeah.
So being the wet lab lead itself is definitely a challenge too, because we're breaking into this new field that no one on our team has worked with before. There was a lot of work that falls upon the leads to understand the literature and to know how to delegate different aspects of literature review, for example, to the members. So we had around 5 or 6 members with us, like in person over the summer working, and so there were a lot of sessions where we were like in a room on campus. We didn't have a goal because we didn't really know what was out there, but we're like, these people are going to be looking in this direction, these people are going to be looking at this direction, and then it's up to the leads to synthesize what research they kind of output and how we can format that into, or like bring that together into a project. So it's a lot of thinking, a lot of brain power. You're constantly thinking about the iGEM project, even when you're technically off of like the 9 to 5 volunteering like hours that we put in. It's definitely a lot of fun. It's a lot of fun. But yeah, there's a challenge to like learning how to manage the team while also learning about the scientific concepts themselves.
And this might be a little bit too specific, but I'm curious, especially because, we have to read a lot of literature reviews and a lot of papers. Were there any techniques you used to kind of get through so many papers? Because I imagine, your team sent you so many different papers and you had to figure out a direction, right, to go in. So were there any techniques you found useful?
Honestly, we used Google Docs a lot, obviously for initial research, but we liked, or a really big thing that helped us was synthesizing the information into spreadsheets and comparing, because ultimately it came down to what primary paper do we want to base our project off of. So we had to compare what is their limit of detection, what is their protocol, what is the design, and what are the implications, limitations, comparing that on a spreadsheet. And we sat down, I remember in a leads meeting for 3 hours,
Wow.
one by one, going through them to see which one we thought we could actually do.
Right.
And that's sort of what happened, and that worked well for us, I guess, but I'm sure there's a more effective way to go about it. I mean, we're constantly learning, so.
Absolutely, yeah.
And just kind of commenting on, obviously your team was immensely successful in the competition. You guys won gold in two, and you won a gold medal, and then you got top 5 in 2 categories. Would you say there was a core philosophy change or any sort of fundamental approach that you took on that maybe you weren't doing before on the team in general, and then actually led to the success? Was there a change that kind of led to that?
Mm-hmm. So I guess there are a couple things. So first, the gold medal itself, it's not that we won the whole competition, but it's more of a criteria.
Yep.
And so the gold medal is given to many, many teams. There's not a limit to how many are given out. It's just what teams meet that criteria. And that criteria is broken down into 3 components. They're called special awards. And so there's a huge list of them that every team can choose to be the 3 that they're competing in. For example, we competed in integrated human practices, in best education, and also in best measurement. And to fulfill the gold medal status, you need to achieve gold criteria across all 3 of those. And so it's reliant on the human practices team for IHP and education, and wet lab for best measurement to fulfill those goals. And the requirements or the criteria is very arbitrary. So that in itself is you do the best that you can and hope for the best. So in terms of that, core philosophy, the biggest change we made was changing one of the events that we were participating in. We changed to best measurement, which ended up to be more feasible for us to do well in. And that really did help us secure that final gold stamp. For human practices, we'd always done very well. We'd always received gold in those 2 categories. In terms of the nominations, overall, I think the biggest thing is that you need to build a tangible product or a holistic project that you can pitch to someone that they can understand and understand the value of it.
Right.
And so the great thing about a diagnostic is it's a physical device that we had printed out, 3D printed out, and you can see how the mechanisms work and how the biological components or reactions take place. And I feel that made it so much more tangible, and it was a project that people can actually see being used in the clinic and at homes. And I feel that is also what helped us gain that nomination for Best Diagnostic project.
Wow, it's really inspiring, hearing all the thought process and, the journey, right? Because so often you only see the result, but, seeing the work that you put in and the rest of the team put in is really inspiring. So I think the viewers out there can really appreciate how much effort and passion you have, for research, especially for, kidney transplants. So now moving on to, a question that a lot of undergrads face. I think we all face this, getting the first exposure to lab, finding these opportunities. It's so daunting and it's very difficult to do. So I'm curious, how does, McMaster iGEM and the iGEM competition help address this problem? Because, a lot of first years come in, they want to get involved in research. They want to be involved in something that's meaningful, right? So I'm curious, how does your team help these students out, help them find a way to contribute to science?
Exactly. So when you come into university, obviously, you don't understand what's out there, and it's very difficult to gain access to research opportunities, especially
Absolutely.
Because, like you said, these labs are very daunting, and it's very scary to reach out to professors. And so the iGEM competition and McMaster iGEM really helps facilitate easing students, especially first-year students, into the lab environment, because we're already technically affiliated with these labs. We have connections with PhD students, with the lab techs, the lab managers, the profs themselves, and that in and of itself really breaks down the barriers to like breaking into research and gaining research positions. And so the great thing is that we are able to relay like opportunities from these labs into our members. Not to say that this is the only like these are the only opportunities that are available to them, but it's a facilitated way for them to gain access. Like in my experience, like I wouldn't have gotten my volunteer position if I had not been in iGEM and known the lab coordinator or the lab manager who would have connected me with my supervisor. And so that is one really great thing. And then also just like for our members in the wet lab and like the iGEM team, they get to see what goes into a research project and they get to gain those skills from scratch, literature review, and I feel like those also are such valuable assets that you can then kind of use, and this is like a very unique opportunity that kind of puts a lot behind you when you're also applying to like project courses, thesis, and like whatever else other research opportunities you might want to pursue. And so like it just is a very nice introduction to research and the lab environment that doesn't require like the really daunting process of like cold emailing and getting all those rejections, which like definitely scare a lot of students.
Right. It's basically like a nice little gateway towards research instead of, I guess, being like a very narrow like cave or something. You know, iGEM helps open up like a nice green path for students who are, you know, they want to get involved but they don't have that much experience. So I think that's wonderful that you are doing that. That's really amazing.
And if I also may add one more thing.
Of course, yes.
We do a lot of like stakeholder interviews. So like we were talking about, you talk with clinicians, with professors on campus, and so we also get all of our iGEM members to send like emails to professors to ask for meetings, and then they actually do conduct those interviews. So you also do get a chance to meet lots of profs on campus that you wouldn't necessarily have the hold or necessarily have the opportunity to meet with them otherwise. And so people gain traction with profs, and you can use that as leverage in your cold email saying, I interviewed you for this iGEM project. Like, do you have opportunities in your lab? So I feel like that also really helps facilitate better access to research opportunities on campus for students. And
just sort of bringing it all together, you're the new co-president for this cycle, obviously. Are there any changes and improvements you're hoping to bring to the team this year? And do you kind of have an overarching idea of how you want to approach your next project?
Yeah, of course. Yeah. One of the biggest things that I wanted to do coming into the co-president position was making sure that our first years had a lot, they were like onboarded well onto the team, and that they were able to contribute to some capacity as well to like the project development, because there's a lot to learn as a first year as well. It's very overwhelming entering this design team that's already like sometimes like very deep into their research. That's something that I really wanted to facilitate, and also just like streamlining the project development process as a whole. Obviously something that you can like calculate, but there are ways that we were trying to make it more streamlined and making sure that everyone has some contributions to make, some valuable contributions to make to our overall project. Yeah.
All right. And just really quickly, is there any way for the people listening who would like to maybe get involved with the team over at iGEM, is there any way for them to go about doing that?
Yeah, of course. So the applications for the McMaster iGEM team, they come out around the competition time, so either before or afterwards. Historically, it's been after the competition, so like in November around, but we hope to try to bring out applications earlier so people get more time to write it. That is like the main way to apply into the club. We do hold like events and workshops like throughout the year that are open to other students at McMaster. For example, tonight we're actually hosting a journal club about a paper that the web lab team has read, and we'll give a little presentation, have discussion that's open to everyone on campus. And so those are some like smaller workshops that we have that students can get more involved in, to meet the members of the team, kind of ask questions about what it's like being on the team, and also how to get more involved in the future too.
Okay. Well, thank you so much, Jiawen, for joining us. I think we're going to wrap it up here. And I think I speak for all of McMaster in saying that we're so proud of the iGEM team, so proud of you guys. You guys are amazing. So thank you so much for all the work you do, and best of luck for your next competition. So thank you to everyone listening, and we'll see you next time on Office Hours Unplugged.
Thank you so much for having me.